First thing I'd like to speak about here is the architecture, the geometry of tissue. Okay, and one of the things that, even if in a 3D world, if we're believers in that and we apply those principles on a regular basis, one of the things that we often neglect is all the spacing in between, right? So when you think about what a directional vector is on tissue, right? Even if we're looking at the obliques here, right? We tend to think of kind of one angle that they run on, and we know that the tissue is completely different from that respect. And with that, we want to be able to appreciate the fact that even if we're working in the three cardinal planes, there's a whole lot of muscle fibers and connective tissue that are running in different aspects. If you look over here to the right picture, and keep in mind that even in a two-dimensional photograph, we can't get the appreciation for depth that's involved. And even with the obliques, keep in mind that they're wrapping around, right? So they're not a straight line in two-dimensional space. So all of those aspects add to different areas or different applications from which we want to be able to get, we want to be able to access the tissue and influence the tissue by what we're doing. And of course, at some level, this can be done manually with individuals, meaning a therapist, massage therapist, et cetera, doing something with you on the table. Still challenging because there's just so many possibilities. So that being the case, part of what we want to consider is what we refer to as myofascial expansion, right? And this is where we really look at, how much the tissue spreads and then the influences onto other structures. And, when you think of somebody that may have a groin strain or somebody that may have just, scar tissue from a previous injury, part of what we've got to look at is not just, for example, where that scar tissue is located, and not just in the most familiar direction from which the primary fibers in any given muscle group lay, but also the expansion to which it goes out in all directions, right? So if I have a limitation in my hamstring and the only thing that I'm doing is sagittal plane flexibility, mobility work, or even for that matter, any of the manual therapy that's done to it, obviously we're neglecting the way that the tissue expands. And along with that expansion is how the proprioceptive system is able to basically interpret that data and how it's processed as well, because we're looking at multiple influences of free nerve endings throughout that tissue. And when we can expose that tissue to this variability of these motions with length and tension, okay, we improve the motor system's ability to respond or react to that particular input and the needs that might be required to either produce force or resist force and reduce the risk of injury from that respect. So, when we think of the myofascial component, of course, that denotes the continuity, they're in separation of the muscle fibers and the connective tissue at the same time. We know they both respond differently to inputs, but they play hand in hand, and you can't really pull one from the other. And basically, in the way that we're going to address them and our needs for mobility as a whole. For those of you that don't have a deep science background on here, interestingly, we've obviously seen with all this situation, we've seen a large input in home users. I'm going to be a little bit geeky, a little bit technical on this, but in general, mobility and flexibility are not interchangeable terms per se. Mobility really involves usable flexibility, things that we can control. You'll see some people have a passive range of motion that is perhaps unbelievable, that you'd never think you'd be able to achieve, but that same person does not have the same motor control and in some cases strength to be able to control exactly that range of motion. So mobility in its simplest form is usable range of motion that we can deal with or we can handle, and that we can obviously utilize in a lot of ways. To me, this is a really powerful quote, and this researcher has done a lot on the relationships of the parts. But in any particular joint position, some of the sarcomeres in a given muscle may be shortened and others lengthened based on local connective tissue connections with other muscles, right? So this particular, when we think about, again, the relationships and the interdependency of the parts, the ability to expose multiple directions and influence multiple tissues with the movements that we're doing, with the long-term goal of improving mobility at certain segments, is certainly to our benefit and ultimately to the user's benefit. And again, this sort of moves us a little bit further along in the understanding of functional and integrated anatomy, and gets us a little bit past the idea that, number one, that we're only addressing kind of the elastic component of the muscle. Number two, that the expansion of all these tissues and the interdependency of them is something that can't be ignored. And then by having the opportunity to explore those, whether it's through the help of a therapist or a coach, or whether it's our own ability once we get on there to sort of seek out where the limitations are, where the greatest resistance is, it allows us to really expose a great deal of the tissue to new influence, new inputs when we have this motion. Because one of the unique characteristics of the design of Core-Tex is not only do you have the X, Y, and Z axis, you also have this translation. So we start to, not only do we get rotations, but we also get depth in what we do. So that translation, if you think of your bumper on the center, as that moves across that bottom ring, what it's doing is it's constantly changing the axes of rotation as it moves, right? So that and then you combine it with the complementary axes and other motions, and now you're talking about just an enormous number of possible exposures that you're getting to that tissue, and ways that we can explore that beyond just something that sits flat on the ground and moves back and forth, side to side, or even rotates if it's horizontal. So the translation and the tilt really give us an opportunity to change joint positions relative to a fixed segment, as well as therefore expose those tissues. And again, using the example of this study, using where certain sarcomeres were lengthened and certain sarcomeres maybe, and muscle fibers ultimately will lend to different changes in length as we do that.